In this video, we're going to compute the following sum. 2 over n squared plus 4n plus 3 with n going from 1 to plus infinity. Okay? We assume that this series is convergent, and therefore we have its sum denoted by s. Therefore, this limit, according to the definition of the sum of the series, exists with the Sn is defined as the partial sum, the nth partial sum. Okay, going from 1 to n, and n is going to infinity. So here the Sn is given by this. Now we're gonna focus on this partial sum. Okay, AK, okay, from 1 to n. Here our AK is given by 2 over n squared plus 4n plus 3. We notice first that we can factor this one. So we can do it this way here. So n squared plus 4n plus 3, we can split this 4n into 1 and 3. So we have n squared plus n plus 3n plus 3. It's going to give us n times n plus 1 plus 3, n plus 1. And we have n plus 1 as a factor, and n plus 3. That means we have this one. Now we're just going to focus on this AK, or a sub n. Okay, so we have this 2 over n squared plus 4n plus 3, which can be written as n plus 1, n plus 3, and we still have these 2. So using fractional decomposition, we can write this one as a, let's say, n plus 1, or k plus 1 plus b over n plus 3. Okay. If we cross multiply, we get a plus b times n plus 3a plus b over n plus 1 times n plus 3, and we equate this one with this one here. So a plus b is 0, because there is no n term in here. There is 0 times n. So we have a plus b is 0, and 3a plus b is 2. So that means a is minus b from the first equation, and we plug here, we get 2a is 2, that means a is 1, and b is minus 1. Therefore, our series, the Sn, becomes the sum of 1 over k plus 1 minus 1 over k plus 3, with k going from 1 to n. Okay. In this case, when we have this kind of telescopic sum, we want to make this coefficient the same. So what we do is we do a quick trick. Okay, so here we're gonna go until we reach 3. So how many elements, how many numbers we need to reach 3? We need 2. So first, when k is 1, we have 1/2. When k is 2, we have 1/3. And after that, we reach 3. So k is gonna go from 3 to n, 1 over k plus 1, minus this one still goes from 3. From 1. 1 over k plus 3. Okay, so now we're gonna do a change of index to make this one look the same or start from the same. Okay, so here we have k plus 1. So if we do here k minus 1 or k minus 2 is L. Okay, when k is 2, when k is 3, L is 1. So we're gonna write this one 1/2 plus 1/3 plus, when k is 3, L is 1. When k is n, L is n minus 2. And here we have k plus 1 is L plus 3. Okay, minus this one here, minus this sum. Okay, so now we see that we can change now this index. Okay, so we can change it 1/2 plus 1/3 plus k, because it's a silent index. We can do k plus 3 here in this last term here. So here we start from 1 and we stop at n minus 2, but here we go until n. We need to stop at n minus 2. So here we stop at 1 over k plus 3 at n minus 2. How many left? 1 left is n minus 1, which is giving us n plus 2, and the last one is n minus 1, which is giving us n plus 1. Okay, so our series, our sums, our partials and partial sums is this one. Okay, now we take the limit. Okay, according to the definition, we need to take the limit of this series. We take the limit to see the value of this one. Okay, so here we take the limit. We have 1/2 plus 1/3, which is 5 over 6. This one is gonna cancel because these two are the same. Okay, and this one goes to 0 as n goes to infinity, and this one goes to 0 as n goes to infinity, and all we are left with is 5 over 6. That means our sum is 5 over 6. Okay, that means here our sum is equal to 5 over 6. There is other ways to check this value, but for us, this is all we get. And this means that our assumption first that this series is convergent is true. Its sum is 5 over 6. Okay, we can do integral. We can do the integral test if we want to do that. So this one is positive, decreasing. If we define the function by f of x, okay, as 2 over x squared plus 4x plus 3, we can use to see the nature of this one. It's convergent or divergent is the same as this integral f of x dx. Okay, if we do this one, you're gonna get different value ln of 2, and it's convergent. Why? Because this is more precise. Okay, this is the exact value. This is an approximate value of this series, because we are using only n's, we missing something. Okay, so that means it's convergent. If you want to check it, you can do the same thing here and see that you get the result that you want. And this will end our video here.